Hello friends, welcome back. Okay, so right now we're going to be learning about symbols. So I'll open that file, about symbols. It's right here. Yeah, so here we go. Let's start off. Just test that symbols are symbols. So a symbol is equal to this guy. And so we're setting a variable name of symbol equal to a symbol, which is this data type. So now we can say symbol is a symbol. So that's just kind of showing us how that symbol works. So if we come back over here to our REPL, I'm going to exit and restart the REPL so that it loses all that old array and data stuff from the previous ones. So yeah, basically, I mean, they're saying Ruby, right? This is, if we go class, we'll see the class's symbol. And so what we're doing right above over here, we're saying symbol is equal to Ruby. So then if we did symbol, we're setting it there. I don't know why exactly we have to declare that, but you could just be like, but so then why, if we go symbol and we say is a, and then we put symbol, this should render out to true, right? Cool. So yeah, for whatever reason, we want to just make this true. So basically this is just showing us that that this is what a symbol is. We've used it in the past, so now it's just kind of making it clear. So symbol 1 is equal to a symbol 2 is equal to a symbol 3 is equal to something else. Symbol 1 and symbol 2. Well, I don't know if those are equal. I think that they are. Symbol 1, symbol 2. And I think that the way we would be able to tell is by going symbol 1 dot object ID and symbol 2 dot object ID. Cool. So because they have the same object ID, we know that they are the same. We could also just throw that in here. So that comes out to be true. Now symbol 3, symbol 3 dot object ID, that has 988028. So obviously, so the object ID is different for symbol 1 and symbol 3. And so that means they're probably going to be not equivalent as well. So we want to say false. So we've learned that symbols can be compared. And so that's what we've figured out there. Cool. So test identical symbols are a single internal object. Oh, symbol 1, a symbol 2, a symbol. Symbol 1 is equal to symbol 2. Yeah, we did that. Okay, cool. We did that on the last one. And so here we've got symbol 1 object and symbol 2 object ID. Those are both the same. We did that up here. Symbol 1 and symbol 2, their object IDs were the same. Cool. So test method names become symbols. Symbols as string. Symbol.allSymbols.map to string. Okay, so what is this doing? This is taking all the symbols that are available in Ruby. So if we run this, it's going to be pretty big because Ruby is a giant library, right? So if we go symbols as string, this is all the different symbols that we have access to. So and, not, empty, equal, basic object, these are all opportunities that you have to do various things in the Ruby programming language. So does it include a test method name become symbol? So if I search for this, I don't see it. Test method names become symbols. That method names become symbols. Okay. Symbol is strings. Well, what happens if we just throw this in the REPL? It's false. So what does that say? Test method names become symbols. That means that method names don't necessarily become symbols. I'm not sure about this. I'm going to run over here and I'm going to run the rake task again just to see if I passed that one. So line 28 is where we fail. So for whatever reason, so this is not right. So I'm going to rerun this symbol names as strings, and then we want to say test method names become symbols. Test method names become symbols. Test method names. Oh, okay. So the reason that it's not working out in the REPL is because I have defined my method here, and yet that hasn't happened in the REPL. And so therefore, the method names, this method name, this is the method, and this is the name of the method. The method name becomes a part of all the symbols that are available for the string. So this is going to be true. So symbols as strings, when this goes through and it shows all the methods that are available to this program, because this one has been named, it can be seen in here. So it is there. So think about it. Why do we convert the list of symbols to strings and then compare against the string value rather than against the symbol? Why would we do it specifically that way? I mean, I'm not sure you could do it into an array or anything as well, but I think that converting it into a string just makes it kind of easy to do a string lookup thing like that. So, okay, cool. So in Ruby version MRI, do Ruby constant. What is the sound of one hand clapping? Test constants become symbols. Okay, so this is a constant. The constant is in Ruby specifically, starts with a capital letter, and then each of the following letters are all capitalized as well. That's not snake case, but I can't remember what it is. But you'll see you have other constants like this, like classes look like constants. So here we say Ruby constant, and we just set it equal to some crazy string. So all symbols, so we're taking all the symbols that are available to this program, which has a Ruby constant in it. All symbols as strings include all symbols as strings. It has this Ruby constant. So we want to say, we want to verify true that all symbols and strings include Ruby constant. And we want to pass it in as a string because we're searching with a string. Cool. And I'm actually going to run this again because I'm not positive about that. Cool. So it looks to me like we're good. Our next problem is on line 47, and that was line 41. So what we're doing is it's just saying we're making a note of the fact that we can convert all the symbols into a string, and the constant variables become on that as well. Like if you were writing a chess application, you might want to make constants be the various pieces and how many there are or something like that. So test symbols can be made from strings. So a string is cats and dogs, and then if we go string to symbol, so we could actually do that in our REPL as well by just doing this to symbol. And then you'll see that it's converted it into a symbol. So that's great. We can say string to symbol. Cool. So we would want the result to be cats and dogs. So the symbol becomes equal. Test symbols with space can be built. So here we've made symbols. I've never even tried to use a space with symbols. Interesting. It looks like it can be written. So cats and dogs to symbol. Well, what happens if we go cats and dogs dot to sim? Then we get that same one. So that's what we want to do. If we want to create a symbol that matches this one, we would just want to go, cats and dogs. And then that will be converted into the symbol that we have saved here. And another way you could just check this is you could just say, instead of doing the assert equal, so you can just double equal it, and that'll render out to true. Cool. So test symbols with interpolation can be built. So here we have a value. Oh, wow. I didn't even know you could do this. You can interpolate symbols. Wow. Or maybe you can't, and it's just a test. So let's throw the value in there and the symbol. And then we just want to print the symbol. And there you go, cats and dogs. So we can make this cats and dogs. Neat. All right. Wow, that's interesting. Test to string is called on interpolated symbols. Okay. To S, that means to string. So our symbol is cats. It's raining cats and dogs. We throw our symbol in there. What do you think it'll render out to? I'm thinking that it's going to render out, it's raining cats and dogs, but it's going to have the colon in there, which is going to make it look weird, I think. Looks like it doesn't. It just, so Ruby's smart enough to clean up the symbol, or the colon in front, which makes it so it's a symbol. And so it's raining cats and dogs becomes the string if you interpolate symbols. For whatever reason, you might need to do that. So we set symbol equal to Ruby, and we assert equal. The symbol is a string. Interesting. So we could go to check this. We could be like Ruby dot is a, and then string. And that's false because it's a symbol. It is a symbol. It's not a string. And so we want to say false. Wait, unless there's something like that goes weird. So symbol is a string. Yeah, that's false. But symbol dot, is it equal to Ruby? And the reason that you would think that it would be okay to be Ruby is because interpolated, it would work like that. So it's not equal to the string of Ruby equal. So this says test symbols do not have string methods. Okay. Oh wait, test symbols are not strings. So this just tells you that they're not strings, and it's not. It doesn't. You can't just say it's equal to a string. Test symbols do not have string methods. So rich symbol, not a string. And then so does it respond to each character? No. Does it respond to reverse? No. So neither of these are true. And that's really what we're trying to do by learning this. We're learning that the symbols do not have string methods. These string methods you might not have seen before, right? But like reverse. So if we had abc.reverse, it's CBA. And so I think you can go abc.each character, and then it's going to enumerate each character. Cool. So that kind of shows you that those are string methods, and you can't use string methods on symbols. It's important to realize that symbols are not immutable strings. So though they are immutable, none of the interesting string operations are available on symbols. Okay. So test symbols cannot be concatenated. Assert raise. So what happens if you try to add two symbols together? So cats plus dogs. It says no method error. So what does that mean? That means that symbols do not operate with the interpolation or the concatenation tool, which is just a plus sign. So that means like something like you can say cats and then you can say dogs like this, and the string will be able to interpolate and we'll be able to concatenate this string and this string, but it won't do that for symbols. To test symbols can be dynamically created. So assert equals cats plus dogs to symbol. Well, this will work because it interpolates them, but the strings are concatenated before it is converted into a symbol. So assert equal. So what is this cats and dogs going to come out to? It's going to come out to cats, dogs, with no spaces. Why is it not a good idea to dynamically create a lot of symbols? Well, because your application could probably just go kind of bonkers if you just do too much interpolation programmatically. Anyways, now we can come back over to our koans in our terminal. If I go pwd, you can see I'm in the folder, and we can just go rake to run the test to see if it worked. So yeah, now we're moving into regular expressions, which tells me that all of the code that we've done here has passed. So I hope you guys enjoyed this one, and we'll see you in the next one where we talk about regular expressions.